All right, thank you very much. We have to start off now. And today's class is going to be very, very brief because most of it is just for us to have an application knowledge and see how we can play with few services within the database and analytics. And what we have today, we just have 6 functions to take a look at. And one of it is the Amazon Redshift, Amazon Athena, and we have to look at what's the next? Amazon, AWS Glue, Neptune, OpenSearch, which was former ElastiCache, and then we'll talk about Kinesis, and that's all. That's all. So we're not going to be wasting or keeping ourselves too long, okay? Like yesterday, we've talked about the DynamoDB, we looked at the Aurora, talked about the RDS and the ElastiCache. So, but today is different. Let's see. So now, Amazon Redshift. Let's talk about it. Amazon Redshift, as you have it here, it actually uses the SQL database engine to analyze 2 kinds of structure of data, that is either structured data or semi-structured data across the data warehouses, all right, and operational database and data lakes using AWS design hardware and machine learning to deliver the best price performance at any scale. So that is about that, best price performance at any scale. So you use it to deliver the best price performance at any scale. And then you think about the SQL, when you think about the SQL database engine and also the structure and the semi-structure. So this have it sticked into your head and it makes it very, very simple. So it's still on analysis, So let's move on to the next one, which is Amazon Athena. Is actually serverless. Amazon Athena is serverless, and it is used to query services and also analyze data stored in Amazon S3. Yeah, that is it. You can see the diagram here. Now, this is the S3 bucket, and these are the users. The users now proving the S3 bucket and then conducting query of the S3 bucket with Amazon Athena. And at the same time, using Amazon QuickSight rather, as for reporting and dashboards. If you have used Qualys in cybersecurity to conduct vulnerability management, I know my friend Benjamin is actually conversant with Qualys. Yeah, because he's a security guru. When we conduct our scanning with Qualys, you know that we can actually organize it in different pockets to get the reports in a way to be well presented for senior management to have better insights of our findings. So now the Amazon QuickSight helps you to report. It helps you to organize your report and organize dashboards for it, just the way we use our Qualys to scan and then organize our reporting. So that's about that. And it supports the CSV version and JSON, ORC, Havro, and Parquet. All right. And it costs $5 per terabyte of data scanned. You see, so it's a scanning tool also, and it's commonly used with Amazon QuickSight, which I have just said for reporting and dashboard. So you have this stick into your head. If you want to organize your dashboard for reporting purposes, Amazon QuickSight becomes your go-to service. All right, and it can use business intelligence and analytics. All right, to analyze query of VPC flow logs and so forth, like the Elastic Load Balancer logs and the CloudTrails. So that is that. That's about Athena. So you pick up, you have those catch there. It's a scanning tool for S3 buckets. In summary, let's run down to the Glue. AWS Glue is still serverless. Serverless means that you do not have to manage servers. It is Amazon AWS that will do that for you. So there are servers, but you would not do it. You would not manage it, okay? So it's a serverless data integration services by the name Glue. glue, that is shows that you're sticking things together. So serverless data integration service that makes it easier to discover, prepare, move, and integrate data from multiple sources for analytics. I want you to get this very clear. In the local understanding of it, I want to import data in DynamoDB, in Aurora, RDS, and so on and so forth. You have data in these kinds of functions, right? Now, this glue has the ability to bring in data from everywhere, all right, and and analyze them. So it can move data from all these sources, put them together. Please, a minute.
Hello.
Yeah, I'm with you. Can you hear me? Can I get the feedback?
Yes.
Okay, so that is it, the glue. So you now talk about the different databases that we talked about, right? In our first class in this week, we talked about the RDS, we talked about Aurora, and we also looked at the ElastiCache, and then we talked about DynamoDB. So in a place where you have data from all of these sources, you still need a function or a service that will be able to move data from one place to another or integrate different data from different sources. So that's what the glue does for us, okay? That's what it does for us. So now Neptune is for analytical also, and is fully managed by, is a fully managed database service built for the cloud, and that makes it easier to build and run graph applications. Now we're talking about reporting, but in a place where we have graphs, or we need graphs, Neptune is the go-to function for us to, build and then run our graphs application. And it actually provides an inbuilt security and continuous backups, and it's also serverless, okay? And also it can be integrated with other AWS services. If peradventure you need to call up graphs for a kind of a presentation from them. So Neptune becomes your go-to function, is for analysis. Then OpenSearch, formerly OpenSearch was ElastiCache, and now it is OpenSearch, all right? And that's beautiful. So OpenSearch provides a highly scalable system for providing fast access and response to large volumes of data within an integrated visualization tool. A large volume of data within an integrated visualization tools, and that would assist us to be able to explore this data, know where they are, get some stuff out of it, no matter how tremendous the database could be. And this is actually powered by the Apache Lucene. Okay, the Apache Lucene library, it's what is powering this, and it supports a number of search and analytical capabilities such as the k-nearest neighbors and SQL, anomaly detection. I can also do that by creating the differences between two data, and also it will be able to let you, identify similar data together and have them grouped. So it's for your trace analytics. It's a full text search and more. So it's for search. And peradventure, you have decided you want to gain access into certain stuff in your database, your OpenSearch becomes your go-to service. Then Kinesis. We've been talking about, I just pronounced it the engineering way, Kinesis. but it's Kinesis. All right, Kinesis. That's the pronunciation. Now we'll take a look at them when we go over to the dashboard. So Amazon Kinesis. All right, it's cost effective and helps you to analyze streaming data at any scale as a fully managed services. All right, streaming, think of streaming data, you talk about Kinesis. So that is the primary function of it. It can ingest real-time data, such as video, audio, application logs, website, click streams, and Internet of Things telemetry data for machine learning analytics. So this is how it works. Okay, when you want to analyze data that are being streamed, Kinesis becomes your go-to function. Now let's quickly look at certain stuff. Let's see how we would be able to see some things. All right. Now I've taken you into the AWS document now. Now let's take a look at it. You see how the diagram works in here. You can see the input, you capture and send data to Amazon Kinesis data stream. You see the Amazon Kinesis data stream ingest and store data streams for processing. You see that? And after that, these are other functions that you can integrate your data with. Sorry. Let's see. You see that we have the Amazon Kinesis data analytics. Now you have the streamed data. The data analytics can now be used to analyze. Then we also have this pack on Amazon EMR. We have Amazon EC2. So the data can actually go straight to the EC2s. All right. If we have EC2 somewhere, it means that we can also have our EC2s, that's our servers, placed in a subnet and have our security group to barricade them as a firewall. And also, it can be integrated with Lambda. When we now start talking about our projects, we would take a look at some projects about this analogy which we have here. All right. So the Lambda actually built the custom real-time application using the Kinesis data analytics, stream processing frameworks such as Apache Spark, like I talked about. So now that is, and just the way we have DynamoDB to RDS, so we have Lambda to EC2. Lambda is serverless, all right? It's serverless. So it's either you're using EC2 or you're using Lambda, all right? So that's it. Let's check some other functions within it. How many do we have? We have what is called the Kinesis data firehouse. Now, the Kinesis data firehouse is an extract, transform, and load. Can you see the go word? Extract, transform, and load service that reliably captures, transforms, and delivers streaming data to data lakes, data stores, and analytics services. That is what the Kinesis data firehouse does. And you see, the same way we have the diagram. Now we also have different analogy here, where the input comes into the Kinesis data firehouse, right? And through the Kinesis data firehouse, we can have the data stored into an S3. At the same time, also move it to Redshift, okay? And then also OpenSearch service, and Splunk, and so on and so forth. Then we now have our output here, where the data can be fully accessed by, or in the transformed pattern that we want it to be when it's been loaded. So that is about that Kinesis data firehouse, right? The first one was what? Kinesis data streams. Now this is firehouse. Now after the firehouse, we now have the analytics. Now the data analytics as the Amazon Kinesis data that the data input is coming in, the Amazon Kinesis data analytics can query and analyze the streaming data. You see, it queries and analyzes the streaming data and immediately gives out an output. You can now have processed data to analytics tools. So you can create alerts and respond in real time. If we talk about creating alert now, we've now started talking about SNS, CloudWatch, alarm, and so on and so forth. All right. So Kinesis video stream is also another function. You can see under the Kinesis group, the video stream, you have the input as a video coming in, but you must have a secure data key. Then the video stream streams it into lots of other functions like the Amazon recognition video and the Amazon SageMaker and lots of them. So that is on this. What else do we have there that we talked about? Let's go back to our, okay, let's take a look at the Redshift and Athena. Okay, let's start with Amazon Athena to see if we can have a diagram like this for analysis purpose. All right. Okay, no, leave it here. Let's get into the dashboard and see how we can conduct some queries, starting with the Redshift. All right. Okay, just hold on a little. We have to start with it. Okay, then we check Athena to see if we are good. All right. Okay, let's say Redshift. Now the Redshift. Okay, before we now continue with this, I want is Sabru still here in the house? Sabru, are you here?
Yes, I'm here.
Okay, I'm going to give you 30 seconds now to quickly go on Google where you are and have an understanding of the meaning of Amazon Redshift, what it does, how it works. So you can read it out back to us. So when you do that, it sticks, all right? So it will not come from me alone, and I'm not expecting you to now start talking about it right from your head. But so now you do that, you can do that. Go ahead. Go ahead and get that done. Are you on it?
Yes, connected. 30 seconds.
All right, the whole community is waiting.
Okay. Can I go on?
Yes, you can.
Amazon Redshift. Amazon part of the larger cloud computing platform, AWS. Okay. It is built on technology from the massive it is built on top of technology from the massive parallel processing data warehouse company.
Okay, Sabro, your network is somehow, I couldn't hear you clearly, but I know you were coming up. But I'm going to give us an explanation, give us an explanation of what we have in here. Okay, so that can help us to understand it better. Now you see, it makes it easier. Redshift makes it easier for you to run and scale analytics without having to manage your data warehouse. When you don't want to manage your data warehouse and yet you still want to analyze and scale your analytics, Redshift becomes your go-to service, and it can give you insights by running real-time and predictive analytics on all of your data across the operational databases. All right, like the data lake, data warehouse, and thousands of third-party data sets. So that is how Redshift works. You leave them where they are, and it goes in there to run the analytics based and leave the data from without trying to ingest it into Amazon. All right, is that clear? Hello?
Very clear.
Very clear. Benjamin, are you here?
Yeah, I'm here.
Oh, beautiful. So now the first thing we have to do is to go in and create clusters, you know. Now we're going to get in and create clusters. When you get them, you see, you hit here by creating clusters, and always the region that you want to keep it must be there. So create. Okay, now you see the Redshift cluster 1, and now the next item is for us to either choose the size of the cluster that we want, or we allow AWS do that for us. Okay, so let's say we want to choose. So we are choosing it, and we move down to want to see the nodes type. That means our CPU. All right. Let's get down. Okay, T2 large is here. T2 large is quite big. You can see the price is already 0.25 cents per node per hour. But let's take it, since it's the least we can get here. The number of nodes, let's leave it at 2. We can now get down to, they have now given us the configuration summary of what we have chosen to say that it's $365 per month if we go on with that. So this is quite affordable. Yeah. So let's move on to sample data. Okay. We leave it the way it is. And then, because you're not going to load sample data. Now for the database configuration, what should we say? What should we do? Say the database configuration, we now say AWS user, like as the admin. All right. We now, if we have to auto-generate password, letting Amazon give us a password, we now take, auto-generate. But how I don't want to do that. I want to pick my own password by imputing it here. My friend Jacob Benny, stubborn guy. So this is about this. If you want to see to ensure that it's what you are, but it has a password convention. It must be 8 to 64 characters long, must contain at least one uppercase. So you must follow the naming convention, the password convention must contain, and then even one lowercase letter and one number. Today is 12, and it looks like a very good day for my friend Benjamin. Must contain at least, can be any printable ASCII character except these ones. Do we have anyone like that? No, we do not. So now we get down. It says create an IAM roles as the default for this cluster that has the, all right. If we want to do that, we can do that, right? Okay, yeah, now if we already have an IAM rule created, we can just go ahead to associate it by taking that. But here now, we do not, I thought we have something here. Let's see. There is none, right? Choose from the existing list. Let's see. There is none, so we can rather create. All right, we always keep our stuffs the way they should be. All right, so now once I click create here now, it creates. And if we wanted to specify the bucket for the IAM role to access, now all your analysis goes to an S3 bucket. That's what it's telling you now. When the analysis is being done, it goes to an S3 bucket because that becomes a data on its own too. So you may want to specify if there is an Amazon S3 bucket created, you specify by hitting that. You know, we created lots of S3 buckets the other day. We have the Benny application 1, we have Benny replication 1, Benny replication 2, Benny cloud front, Pequena cloud front, and so on and so forth. We did a lot of things as that. So let's go with our guy, Benny. Now that he's calm, we would have to encourage him to remain calm. All right, so that is that. And we say create. That goes right in there, right? Automatically. So we move on. Now it's showing us Amazon Redshift command access rule, Amazon Redshift command not applied. So we may want to apply this one or this for command access rules. All right. So this is the default. So let's take off the default. We move down to see additional configuration. In this additional configuration, if we want to use the default given to us, we toggle this stuff. But if we want to get in there to have things arranged ourselves, what do? We remove this, right? Yeah. So now let's get in. Beautiful. Network and security. I know you're thinking, what can come under network and security? Let's see. So now if you're being asked certain questions on how to secure your Redshift, you have to now think of the functions that you're going to be seeing here by creating a VPC. All right. And also creating a security group. Okay. The default VPC is already there. So you move down to the security group. You know, we've taken a security group there. The default security group is taken. So you now see how your reports can be, your analysis rather can be secured. Now you can also pick a cluster subnet if there is any, and the availability zone that you want it to be. No preference. So that is that. Then you are good. But you can have everything automatically created for you. It said enhance VPC routing, turn off. If you want it to be accessed publicly, you don't want to do that. If you want it to be accessed publicly, all you need to do is, but you don't want a public access, so you would not check that. And you go down, let's take this up. Let's go to database configuration and configure our database. Our database is a dev database. You may want to improve on the name and the database port. The default The parameter group is default Redshift. Should we encrypt? No, let's disable encryption. If you further want more security, you can encrypt, or you toggle the use AWS key management service. You use or use a hardware security model. This is like a token that you would use. So let's leave that. So if it is okay with you, you go in and create your cluster. All right. And for the maintenance purposes, what do we have? You want to schedule your maintenance by say use default maintenance window. This is for maintenance purposes. All right. If you don't want to use default, you can say, okay, for every Sunday, I'm coming. Yeah. So you now, can you hear me?
Yes.
Beautiful. So that is that. You now pick the time because, and now you now create the maintenance track. If you want to use the previous version in trailing, you use that. If you want to use the current version, you now take what you want. So let's say the current version. And so what we have here is once a week, right? So how do we monitor? Now, all these things which you are seeing here are teaching you how AWS works. These are projects on their own. Now, can you see that we have VPC being integrated with Redshift, creating a S3 bucket at the same time? Now we are into monitoring. And what is showing here is the CloudWatch alarm that we talked about. Wow, it was as if we were visionaries, that we can see the future of AWS. Wow, so that is that. So it's either you say no alarms or you create alarms. So let's say create alarms, and I get down. You say, then it will notify you when the disk usage is about 70% used, or if that is too much or too low, you may want to change it. But the list is 70%, right? So let's say 95, but 95 will be too close. So let's move down to 75, right? So then you notify SNS. Wow, that's why they would ask you, do you have an hands-on experience? Have you been provisioning this? Because there's no way you will configure Redshift. You will not know the functions that are integrated with it. Now we have SNS. That is the notification service, the simple notification services. Okay, with that you can create topics and have them arranged in a way that you would be notified by messages. Okay, so we may want to pick the default CloudWatch alarm topic that is already there. So how do we now secure analysis that would be in the S3 bucket? Let's see it. We have to create backups. Automate snapshot retention period. Specify how many days to retain automated snapshots, you see? You now pick it if it is 1 day. If you want to conduct manual snapshot, and if you want to configure cross-regional snapshot, that is what the snapshot would be taken to a different region. You now enable it. All right, once you enabled it, it will ask you for the region that you want it to be placed in. Then, aside that, the retention period too can be selected. You may say, okay, you keep my snapshots, all right, for if after 10 days nothing happens, you can delete them because it's expensive to hold them. You may want to choose a snapshot copy grant by Now that we do not have, you create a new one. Then you may give it a name. Benny McIver. Benny McIver. That is his great name. So now, if we want to customize encryption in the snapshot, in the backup, what do? We say we toggle this. And you know, each time you toggle something, something happens. It gives birth to another option. So you can carefully describe them. And if you want to create a key so you can be in control of that, all you need to do is to create an AWS KMS. So that goes, and then we create our cluster. Wow. That is beautiful. That is beautiful. We create our cluster. Is that not good? Any suggestions? Any contribution?
Yeah. I want to ask a question. On this database, I realized that the cluster, always, come on them. Does it mean each database come with a cluster or what?
This is for, yeah, the truth that you need to understand it is that when you hear the word cluster, it is the ability for things to be kept in this disintegrated way, that you organize what looks like what in a different, it's an analysis, right? So you create the cluster, so it analyzes things that looks like themselves into a particular cluster and so on and so forth. So that is about you creating the cluster of it, so you know that all your data are not muggled all up together. It's not all of them that deals with clusters. Some, yeah, would have partitioning, some will have tables, and so on and so forth. It depends on which one you are working on.
All right.
Okay. All right. So what else? Let's just peep through the Athena. Okay. Okay. So who else is there with us? I'm coming. I want to check who else is there before we move on. Oh, this is a sad news. It's a sad news. All right, I think we should call it a day here. Every other provisioning, we will get the videos down so you can go and practice and be good. So my encouragement to us is to ensure that we provision all what we have been taught, not letting